All right, so welcome back to part 3 of section 2.2. We're going to solve another system. So first step is to make sure it looks right. I think it does look right. X's, Y's, Z's, constants are good there. Second step is to encode this matrix. So I'm just going to copy it down. So the first row will be 5, -4, 2, 6. The second row would be 5, 3, -1, 11. The third row would be 15, -5, 3, 23. Okay. I'm going to put the matrix into my calculator. So back to matrix, over to edit. It's a 3 by 4 again. Remember, the number of rows by the number of columns. So this is a 3 by 4, 3 rows, 4 columns. So enter, enter. First row is 5, -4, 2, 6. Second row is 5, 3, -1, 11. Third row is 15, -5, 3, 23. So I've got my matrix into my calculator. Let's see. Now I'll take this. Oh yeah, okay. So back to matrix, over to math, look for the command RREF. Oh wait, no. I forgot to quit out, and if I forget to quit out, then it tries to put the command inside the matrix, and I don't want that. So I'm just going to make sure that says 23. Then I'll quit out of there, and I got to go back to here. But I'm lazy, so I'm just going to go up and grab the command again. And it gives me this. Uh-oh, that doesn't look good. Maybe if I turn it into fractions, it'll look better. Well, that's not terrible, so let's copy that down and see what that says. All right. So 1, 0, 2/35, 62/35, 0, 1, -3/7, 5/7, 0, 0, 0, 0. Okay, now I'm going to try to figure out what this is trying to tell me. So let's read this matrix and see what it says. Okay, so the first row of the matrix says, I'm going to come over here. First row says X plus 2/35. Why did I write 2? 2/35 Z equals 62/35. The second row says Y minus 3/7 Z is equal to 5/7. And the third row says 0 is equal to 0. Now this third row being all zeros actually isn't a bad thing. It just simply means that when we look at what it translates into, that we have a what do we call this? Oh yeah, this is one of those systems with lots of answers. So it's a dependent system with infinitely many solutions, or we have to parameterize the solution. All right? So that row of zeros is actually a good thing. All right, so what does this boil down to? Well, 0, 0, 0, dot, 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 1, bad. 0, 0, 0, 0, dot, 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 0, good. 0, 0, 0, 1 means no solutions. 0, 0, 0, 0 means many. Solutions, and we just have to parameterize the system. All right, so in section 2.2, my goal in section 2.2 is to solve systems of equations. My job is to solve them using a technique called the Gauss-Jordan technique. Now, the Gauss-Jordan technique can be done by hand, but realistically, it's a technique that should be done using some sort of technology. So we encode the matrix, throw the matrix in the calculator, run the command RREF on that matrix, and then decide what the solution means. Does it mean no solutions, many solutions, or one solution? Okay. All right, let's try another example here. Looks like it's going to be a word problem, so we'll have to read it, write equations, encode the equations, have the calculator run the solution for us, and then interpret that solution. All right, let's see what we got here. Okay, so manufacturer purchases a part for use at both of its plants, one in Roseville, California, one in Akron, Ohio. Okay. The part is available in limited quantities from 2 suppliers. Each supplier has 75 units available. The Roseville plant needs 40 units. The Akron plant needs 75 units. The first supplier 70 charges $7 per unit delivered to California and 40 to Ohio. The corresponding cost for the second supplier $80 to California and 120 to Ohio. The manufacturer wants to order a total of 75 units from the first, less expensive supplier, with the remaining 40 to come from the second supplier. If the company spends $10,750 to purchase the required number of units for the 2 plants, find the number of units that will be sent from each supplier to each plant. Wow, that's a big problem. Okay, so it sounds like, based on what they're asking us right here in this last bit down here, it sounds like there's 4 unknowns. Because if I have to find the number of units that should be sent from each supplier to each plant, then I need 4 variables to do that. I need an x1, which would be plant 1 to California, an x2, which would be plant 2 to California, an x3, which would be plant 2 to Ohio, and an x4, which would be plant 2 to, oops, that should be plant 1 right there, shouldn't it? From plant 1 to Ohio. There we go. Okay, well, that's not too bad. Let's see, what do I need to do here? I need to write some equations now that I've got my variables assigned. The Roseville plant needs 40 units. So that means California needs 40 units. So that means that x1 plus x2 needs to be 40 units. And the Akron plant needs 75 units. So that means that x3 plus x4 has to be 75. The manufacturer wants to order 75 units from the first plant. So that means that x1 plus x3 has to equal 75. And then 40 from the cheaper plant. So that means that x2, or from the more expensive plant, sorry, plus x4 must equal 40. And then we're going to spend a bunch of money, so we need a money equation. So then 70x1, $70 to send to California from plant 1, plus 90x2 plus 80x3 plus 120x4 must add up to the 10,750 that they spent. Okay, I think I've got a system here. So now I'm going to encode this as a matrix. How big will this thing be? Well, it's going to be a big one. Let's see. So the first equation is 1, 1, 0, 0, 40. The second equation is 0, 0, 1, 1, 75. 1, 0, 1, 0, 75, 0, 1, 0, 1, 40, and then 70, 90, 80, 120, 10,750. Now, one thing I'm hoping that you're noticing is that we have more equations here than we truly need. I mean, we're going to use them all because it'll help us get our solution. But what I'm saying there is, traditionally with 4 variables, we only need 4 equations, and we've got 5 equations. So when I run this calculation, and those ones end up on the main diagonal, that's going to be our main diagonal right there. So it's going to be interesting to see what happens with this last row when I run this in the calculator. So I'm going to go ahead and do that. Come over here to my calculator. I'm going to go ahead and take this matrix and put it into my calculator. So second matrix, edit. How big is this thing? Well, there's 1, 2, 3, 4, 5 rows and 1, 2, 3, 4, 5 columns. So this thing is a 5 by 5. First row is 1, 1, 0, 0, 40. Second row is 0, 0, 1, 1, 75. Third row is 1, 0, 1, 0, 75. The fourth row is 0, 1, 0, 1, 40. And the last row is 70, 90, 80, 120, 10,750. So again, this is the place where mistakes can be made. So I'm going to check column by column. That last column looks good up there. Column before that looks good. 0, 1, 1, 0, 80, that looks good. 1, 0, 0, 1, 90, that looks good. And 1, 0, 1, 0, 70, that looks good. So now that I've got that, I'll quit. Second matrix, over to math. RREF on matrix A. And I get this. Uh-oh. I'm going to try to understand that. All right, so something here doesn't make sense to me. How can the answers be decimals? So I must have made a mistake somewhere. So I'm going to go back and check my work. And I think I found my mistake. That 90 and that 120. I think my money equation is wrong. Because the problem reads that it's $70 to send to California and $90 to send to Akron. And I've got, this should be there, and that should be there. So my last equation really should be 70x1 plus 80x2 plus 90x3 plus 120x4 is equal to 10,750. It's a good thing I caught that. So I'm going to go back and change my matrix. Oh man, making mistakes is a pain. But I'm glad I saw something that made me think it was wrong. 70, 80, 90, 120. Okay, so now quit out of there. Run that command again. Ah, that feels better. Oh, but wait a second. Something weird's still happening. What is going on there in row 2? All right, so I'm going to copy this matrix down and then see if I can make sense out of it. Okay, so let's see. The first row says 1, 0, 0, 0, 40. The second row says 0, 1, 0, 0, 2.6 e negative 11. The third row says 0, 0, 1, 0, 35. The fourth row says 0, 0, 0, 1, 40. And the fifth row says 0, 0, 0, 0, 0. Right? These zeros down here, well, I don't know what that's going to mean, so I'm going to see if I can figure this out. this first row says that x1 is equal to 40. The third row says x3 is equal to 35. The fourth row says x4 is equal to 40. What does this mean, though? What does this second row mean? I'm not sure I understand that. Okay? I mean, if I read it off directly, it means that x sub 2 is equal to 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2, 6. You know what I think that is? I think that's the calculator's way of saying 0. But it couldn't quite get there. So it looks like our solution for our system is that x1 is 40, x2 is 0, x3 is 35, x4 is 40, and that row of zeros on the bottom is just what happens when you have more equations than variables and you're solving using this system. But we still have a problem. This isn't the answer because we made up those variables. I made them up here. And so if I need to answer this problem, I have to answer it in terms of the original setup. And so X1 meant plant 1 or supplier 1 to California. So they need to order 40 for supplier 1 to be shipped to California. They need to order 35 for supplier 2 to get shipped to California. And they need to order 40 from supplier 2 to ship to Ohio, to Akron. They will order none from supplier 1 to Ohio. Okay. All right, so I'm solving systems of equations. I'm at 17 minutes here, so I'm going to stop this video. We'll come back and do the last one in the next video.